An overview of Assisted Installer for bare metal servers provided by Red Hat's OpenShift container platform. Kubernetes cluster in general consists of nodes that can be implemented on bare metal or virtual machines, and these nodes provide control plane and/or worker functions. The control plane can be non-redundant or can be redundant in 3 or more nodes. Control plane and worker functions can be collocated in certain scenarios. While not mandatory, nodes often connect to the same machine network via single interface or bonded interface. If there are other physical interfaces on the servers, they can be used, for example, for dedicated storage or for extra networks. OpenShift provides several ways of installation for on bare metal servers. One of the methods that is explored in the context of this video is interactive method called Assisted Installer, which is web-based, requires connectivity to Red Hat's cloud. In the UI, you will need to run through multiple steps. In some steps, you need to provide some information, some inputs. In some other states, you need to validate the inputs and hit proceed. And finally, when you create the cluster, you simply need to wait. Probably the most critical one is the step number 4 for host discovery, where based on the previously defined inputs in step 1 to 3, Red Hat's SaaS is generating an ISO image for the bare metal server. And you need to boot your servers from this ISO, hoping that the servers will call home, and so the host discovery will show all the servers that were booted from ISO. Here you will define cluster name and domain, OpenShift version, CPU architecture. You will say whether you want to have a single node deployment or maybe 3 control plane nodes for high availability, or even more for HA+ and HA++ type of deployment. You also make a selection between the DHCP only type of deployment, or maybe you want to have more control over the network settings of every server. That's where you would select a static network configuration. From my experience, static network configuration is almost a must. So I want to control how the servers connect to network, especially since the servers may have multiple interfaces. And I want to have a very specific control which interfaces in what way are used to connect to the network. And then per host, I need to define in the nm state YAML syntax my network connectivity configuration. So I will select, here I have only one interface, but I could also have pair of interfaces in bonded mode, maybe with some VLAN trunk, VLAN ID over those interfaces. I need to also define MAC to interface mapping once I define the nm state YAML syntax. And I have to do that for every host, for every node in the cluster. In this step, I can select operators that will be installed once the cluster is fully operational. When you proceed to step number 4, you expect to see an empty table waiting for host. There is a button on this page, Add Host. You click this button, and that's the place where you will define an ISO parameters, meaning you select the ISO size, whether you want to have a full image file or a minimum image file. You define the SSH public key, a single public key of a host from which you will be able to SSH to the cluster nodes when they are installed, or in case when the installation should fail, you can also access these nodes using that SSH public key to understand what went wrong, get the logs, etc. So you really want to define one SSH public key here. You also may want to define, depending on your environment, HTTP, HTTPS proxy settings. And once you are done with these settings, you hit Generate Discovery ISO. This is one and single ISO that you need to mount later on to your servers. There are different ways that you can boot the server from ISO. One way is using the KVM. Another way is to configure the server's virtual media and boot over the network. You should wait until all the servers that were booted from ISO are discovered. You probably may still need to change the host names of the server because they can default to the MAC address. You may also need to click on insufficient status to fix up the NTP configuration. If you have more than 3 servers, you may need to manually apply the master and worker role for every server. In networking section, you have so-called choice. You can select OVN. And then you can configure your machine network CIDR, so the IP subnet for the Kubernetes cluster nodes. You can configure your cluster network CIDR, so for the pods, service network CIDR for Kubernetes services. And in case you have a proper at least 3-node cluster, you also need to assign or configure API and ingress IP addresses. And pretty much once you review all the inputs, you press the final button of installation, and then you simply need to wait until the progress goes to 100 and all the servers are configured and cluster is fully operational. Then you can access the cluster's console, or you can SSH to the cluster node to continue with day 2 operations. When you access the Kubernetes cluster node, OC and kubectl command line tools are ready. However, the pipconfig is not automatically uploaded to these servers, so you need to download that in the previous step from the installation GUI, and you need to upload that and the proper location on the node, assuming your operational practice is that you want to run your OC or kubectl commands from one of the Kubernetes cluster nodes. You may want to also install another CLI tools like Helm or virtctl. So that depends a bit on how you actually operate the cluster, whether you have a jump host from which you do these actions, or you SSH to one of the nodes to perform these tasks. OpenShift Assisted Installer is providing a very solid way to so-called seamlessly install the OpenShift cluster on the bare metal servers. However, there are a few problems associated with this procedure. First of all, by definition, it's manual. It involves lots of typing, which means you may have fat finger errors. You have to perform likely per server nm state configuration, and this nm state configuration only gives you the syntax validation. There is a single ISO that you boot your servers from, which is good, but you still need to perform per server configuration to boot from this ISO, either via the IMC in the context of Cisco servers or KVM, which is time consuming. There is no support, to my knowledge, for third-party CNI like Cilium or Calico in the context of Assisted Installation UI. Your only choice is OVN. And while Assisted Installer installs fully operational cluster, you still may need to perform several post-installation tasks. Maybe the CLI tools that I mentioned. Maybe you will want to change your authentication to console of your cluster from kubeadmin to something like HT password identity provider, or integrate that with an external authentication system. Maybe you may need to install some extra operators, and once these operators are installed, you may need to further configure them. And a very important topic, the hard dependency of your success is your network. You are configuring loads of parameters which are very much network centric. IP addresses, VLANs, bonding, your gateway IP, DNS IP, and TP IP. You define the interface MAC addresses in the NM states dialog, which have to be on any of the server's physical interfaces. You define the node IPs, API and egress IP. You simply assume that these are free resources and valid resources. And I call it ships in the night because the assisted installer is not helping in verification if these values are correct. Please check the other videos how these problems can be solved.